This video will look at power and electrical power. Now let's talk about power. Power is the rate of doing work. In this example, we have two people moving the same distance. Both people expend the same energy. The jogger takes less time and has more power. The walker takes more time but has less power. The symbol for power is the capital letter P. The SI unit is the watt, and the unit symbol is the capital letter W. By definition, power is 1 watt if 1 joule of energy is transformed in 1 second. The equation for power is work over time, where power is in watts, work is in joules, and time is in seconds. In this example, we have two forklifts lifting a load of 200 kilograms each. The yellow forklift takes 2 seconds to raise the load 2 meters. The green forklift takes 8 seconds to raise the load in 2 meters. In the case of the yellow forklift, we can calculate the force because we have the mass of 200 kilograms and the acceleration due to gravity is 9.81 meters per second squared. The result is 1,962 newtons. We can calculate the work because we have the force of 1,962 newtons and a distance of 2 meters. The result is 3,924 joules. We can now calculate the power, which equals work over time. The time is 2 seconds. The result is 1,962 watts. In the case of the green forklift, the work is the same because we have the same mass and distance. The result for the power is different because it takes 8 seconds to lift the load. Power equals 3,924 joules divided by 8 seconds, and the result is 490.5 watts. Mechanical power is a rating of how much work a machine, such as a motor, can do in a certain time. The mechanical power produced by a motor depends on its speed of rotation, the torque it is delivering at that speed. This is the equation for the calculation of mechanical power for a rotating machine. P is the mechanical power in watts. 2 pi relates to the circumference of a circle. N is the number of revolutions per minute. Tau is the torque in Newton meters. The constant 60 converts RPM to seconds. Efficiency is the ratio of input power to output power expressed as a percentage. When a device transforms energy from one form to another, some of the energy produced is unwanted. In the case of an electric motor, we may provide a power of 1 kilowatt input. We measure the mechanical power out and we get 750 watts. The other 250 watts is what we call losses. This could be in the form of heat, noise, stray magnetic fields, and vibration. Electrical power is the power dissipated in the resistance of electrical circuits. 1 watt of electrical power is dissipated in a resistor when a voltage of 1 volt causes a current of 1 ampere to flow through the resistor. Power equals the voltage multiplied by the current. Power is in watts, voltage is in volts, and current is in amps. With this circuit, we have 24 volts across a light globe, and there is a current of 1.5 amps. Calculate the value of the power dissipated by the lamp. Write down the equation. Substitute the values for voltage and current, and write down the units. Calculate the result. An equation triangle can be used to help in remembering the equation, just like the Ohm's law triangle. Sometimes you may want to calculate power if you only know the current and the resistance. Write down the equation for power equals voltage times current. Now write down the Ohm's law equation for voltage equals current times resistance. In the power equation, substitute the voltage term for the Ohm's law result for voltage. Power equals current times the resistance times the current. This can be simplified to power equals I squared R. To determine the current from the previous equation, you will need to transpose the equation. The current equals the square root of the power divided by the resistance. Further transpositions can be done. Sometimes you may want to calculate the power if you only know the voltage and the resistance. Write down the equation for power equals voltage times current. Now write down the Ohm's law equation for current equals voltage divided by the resistance. In the power equation, substitute the current term for the Ohm's law result for current. Power equals voltage times the voltage divided by the resistance. This can be simplified to power equals V squared on R. Further transpositions can be done. The equation wheel can be helpful in determining which equation to use when performing calculation of circuit parameters. You might find it easier to learn how to transpose the equations. These next examples show the effect on power if the voltage changes. We have a 10 ohm resistor, we have 5 volts across it. What is the power dissipated? If the voltage is doubled, what is the new power dissipation? As you can see, if the voltage doubles, the power goes up 4 times. These next examples show the effect on power if the current changes. We have a 10 ohm resistor, we have 2 amps through the resistor. What is the power dissipated? If the current is doubled, what is the new power dissipation? As you can see, if the current doubles, the power goes up 4 times.